welcome to our SMO senior discussion. This is something that many of you have been waiting for. Thankfully, if you're here from open, I guess consensus is open is not so bad, right? So your brain is not so fried. In fact, yeah, consensus is also that open feels more approachable than senior, right? That is true. So hopefully if you came from the SMO open this morning, you are feeling a bit better than you did yesterday if you were taking the SMO senior. Now everyone's going to keep on asking about cutoffs for the entire duration of this video. As always, I will start with the caveat that I don't know exactly and I cannot confirm anything, but I'm going to get an opinion forced out of me anyway, so I might as well just like express my opinion, right? Now, first of all, for everyone who is taking this SMO senior, you know that the number of participants for the SMO senior is about 3,000 for the last few years anyway. I don't know if it's going to change. Obviously, I have no specific stats, and then there'll be about 100 to 110 or 120 for round 2. It's around there. I think closer to 100, but well, it's not the top 10%. That is not true for any of the categories. It is closer to something like 3 to 4% of the participants. Now, why I'm saying this is that the important thing about the round 2 cutoff is about how do you imagine the 100 best student would feel about this paper. Not how would the top 10 students feel about this paper, but also not how would the median student out of 3,000 feel about this paper, right? Neither of those have any impact on round 2. Now, I feel that for this year, the difficulty is still only apparent for the top students. When I say top, however, I'm talking more about the top 20 to 30. Like, the questions still are familiar to about 20 to 30, but it looks hard enough. Nobody likes a combination of trig, geom, NT, and basically just a lot of trig, geom, NT, and weird algebra. Right? This is more or less the combination that we got for the senior. And I think for many of you who are taking the SMO senior, you're kind of expecting trig. I mean, by now you expect it, but not so much weird number theory, maybe not so much weird geom is definite, and the weird algebra, of course, your mileage will vary on how weird is weird. Now, I think it would affect enough people, as you can tell, it would affect enough people that the cutoff would drop. Now, how much would it drop to? My initial opening guess is somewhere about 12 to 13. Conservatively, because there are still 10 doable questions and some guessable questions. So that's my conservative estimate. It could be lower based on the amount of roaring that I hear. So I do think that the cutoffs for silver, bronze, and honorable mention may drop more, because that refers to, let's say, the top few hundred students, maybe up to 1,000 or so. And if you're talking about the 1,000th best student that is taking this SMO senior, I think they will find it really hard. So if you're talking about my guess, I think it's possible for silver to go as low as a 9 to 10, although I think 10 is more likely, because it starts to shrink down. There are still at least going to be 10 questions that can be done for a significant number of students, where significant is in the 100 plus. Right? So this, maybe? I'm still going to go with 2 mark boundaries, because I think that it is quite unlikely to go any lower, simply because people can still make guesses. Now, do not take this as fixed. Do not take this as a some insider knowledge. Okay, but this is just what I think. Anyway, the truth is that I don't know exactly what the scores are going to look like. Even right now, as you guys are chatting and sharing your painful experiences for senior, which I can clearly understand, my opinion may also change through this stream. And maybe your opinion will change through this stream, so we shall see. Yeah. The usual things apply before we start. As much as many of you have seen the previous few years of my review videos, I normally have a brief introduction. I think I don't need to do that anymore, but just please be polite, please be considerate to one another. You know what, I'm nervous when I do a stream, right? And so I understand that many of you are nervous when you take the SMO, because it means something. And especially for those of you who are taking SMO Senior, some of you are taking it because of you're hoping to, let's say, get a DSA into a JC. There may be other reasons why this is important to you. Maybe you've just done a lot of preparation. So understand the anxiety. And I'm going to kind of take this stream as a way of almost doing a stream of consciousness kind of review. What I mean by a stream of consciousness review is many of you looked at this and kind of got a fright. How do you respond to that fright is going to be a lot of frantic talking to yourself. Not audibly, but just like, why is it like this? Why is it like this? What's going on? Why is it so hard? Why is it like this? Why is there so much geom? Why is there so much trick? Why is there no combi? Why? So it is okay to do it in a very frantic way. It's okay to do these questions in a way of like, why are the questions so weird? Why is the question distribution so weird? Why is it this question is so hard? And also, why do the calculations take so long? Because there are quite a number of calculations to do. Right? We can take that approach. And the overarching theme that I want to convey for all of these is that it's not going to be impossible isolated questions. Even though the paper as a whole can be hard, take each question as its own thing, try to reason it out logically. Even if you're panicking, you can still be logical. So question 1. Now I had a good laugh when I saw question 1. I had a good laugh because it has been never that they open up with an AMGM question. It is not normal to open with an AMGM question. Of course, what I mean by that is that this is a one-line AMGM. This has to be greater than or equals to 90 for all x, and therefore if it's greater than 90 for all x, your A would be 89. But as it's going to be the theme for many of today's questions, not today's questions, this review of SMO Senior questions, there are alternatives. For example, in question 1, you could also take this as a discriminant question. Just let y equals to 2 to the x, and then take this as a quadratic. It's a quadratic because y is positive. You can multiply both sides of this equation without having to flip any sign. And now for it to always be positive, the discriminant must be negative. So a squared is less than 8100 and a is less than 90. So this would also give you the same answer, 89. We are going to try to do this as much as possible. We are going to try to look for contingencies. If the SMO Senior continues to be like this difficulty and future you is watching this in 2025, this question looks like it could have been from 2025, then we're going to talk a lot about contingencies and how to get around things that you don't know, although certainly you would like to have prepared all of these things before the SMO, but during the contest, we do what we can. Okay, question 2 is okay. As long as you know your log identities, you know that the trademark of log fractions is that when you take a reciprocal, it just flips the direction of the log. So welcome to everyone just joining in. I talked about the cutoffs at the start of this review video. And so if you have any questions more about cutoffs, we will address them again later in the next intermission. Okay, so this is your rule for logarithms. Just combine them. It telescopes, and then 7 to the x is just 2024 over 2021. Question 3. Simplify 2024 over root 4 plus root 12 plus 2024 over square root of 4 minus root 12. Now, if you were to do this question properly, it's not very hard, as long as you have the requisite knowledge. But assuming for someone that does not know this, how to handle these kinds of nested square roots, honestly, I would say just go for some rough estimation. Right? Square root 12 is roughly about 3.5, and then after that, just estimate. Really, just estimate it to 1 dp, and you will be able to quite easily get the answer by the fact that these 5 options are very far apart. Now, all of you are sharing your various trivials with the SMO senior. If you're sharing your various trivials, which for many of you includes a 1-digit score, I think you would agree that getting 2 marks is statistically significant. 2 more marks by any means necessary is significant. So all of these kinds of cheats or just ugly solutions, don't throw them out. Now, having said that, the standard way of dealing with these kinds of nested surd expressions is relatively simple. At least there are 2 ways of handling these kinds of things. Now, the first way is to handle them in isolation. For example, I guess that this looks like a combination of, well, at most 2 square roots. I square both sides. This is 2 root 3. So I am going to look for a plus b that's equal to 4 and ab that's equal to 3. Clearly this is from 3 and 1. And likewise, the conjugate, square root of 4 minus square root 12, is going to just be square root 3 minus 1. Once you have this, you can factor out 2024, and it will be just 1 over root 3 plus 1, 1 over root 3 minus 1. Don't need to rationalize them separately, just add the 2 fractions, because that's going to have the same effect. So this is 2 root 3, this is 2, and your answer is 2024 root 3. Now what I'm saying is about the guessing is that in just one instant computation, you know that this thing here is more than 2024. So the fact that it's more than 2024 and you're adding something else means that you can quite easily eliminate the first three options already. And you can also eliminate option E with a little bit more estimation. That's what I meant by being able to guesstimate. Now, an alternative is that if, let's say, you factored out 2024, you can call this thing x and just square it as well. Squaring it is going to take a little bit longer, but it's not so bad because when you square it, you can now simplify it. So square root of this times this is going to be also simplifiable. So I will leave the computations for you in this alternative approach as well. For many of these SMO senior questions which have a lot of algebra, sometimes you are, what happened to my Microsoft Word? Okay. Sometimes you're going to have people think that there is just one specific method and then it gets very intimidating. Just rest assured that there is usually more than one way to do it, and so it is not nearly as bad as you think. Okay, now my Microsoft Word seems to be acting strangely. Let's see if I can get it back to normal. Yeah, so as I said during the junior stream yesterday, I'm just using Word because it lags a bit less. It's not very nice looking, but it doesn't lag as much as the Miro board I was using last time. So if you are slightly annoyed by the visuals of how the question is presented, then sorry about that. Okay. Question 4. I don't really like roots very much. Now you're going to see that also for today, there are lots and lots of situations where you just want to substitute away all the ugly things, if you can. There are lots and lots of instances where the question is intimidating you with ugly numbers, ugly expressions, and it's distracting you. Just get rid of it and it can help you to make a bit more sense of things. So this is a plus 12 equals to b, and you want to minimize b cubed minus a cubed. So I just put it in. I know that a cubed is going to cancel out, so I am left with a quadratic. That can never really be too bad. Of course, this is not the only way. You could also have factorized b minus a, put in 12 and then handle this one. Again, alternatives exist. Okay, so no reason why a cube root cannot be negative, so I can make this thing 0. And so the answer is 432. So, final multiple choice question, number 5. I like to refer to cosine 2x as a shapeshifter. In the world of Trigo, there are many identities that you can only use in one way, right? Like sine 2x, there's really only one way to use sine 2x. If I gave you cosine a plus b, there's really only one way to use cosine a plus b. If I gave you the sum to product, there is generally just one way to use sum to product. But for, let's say, cosine 2x, you have choices. I like to think of trigo, and there's lots of trigo today as well, as being a sequence of either forced or flexible choices. Now the forced choices, as long as you know the identity and you use it, you are fine. But the decision making point is very important. So in things like this, you have to look and see which one goes well with the rest of the expression. And the answer is this one, because of the difference of squares factorization. So cos squared x minus sine squared x, you factor out cos x plus sine x, you're going to be left with cos x minus sine x. At this juncture, for cosine x minus sine x, you can just use your R formula. You don't need the full R formula, because the R formula tells you that the R stands for range, and it is that for a cosine x plus b sine x, the maximum is root a squared plus b squared. This is your R. It's also true by Cauchy-Schwarz. So this portion is at most square root 2. Overall, then this is going to be just at most 2. Answer is D. It is also true that this thing here is actually equal to 2 cosine of, and I'm trying to do a mental R formula here, I think it is x plus 45 degrees. And so if I am not mistaken, yeah, this is what it should be equal to. Yeah, of course, the question doesn't mention something like, okay, sine x plus cosine x is not 0. It doesn't mention that, but that's not a possible value, that's just undefined. So even though they forgot to mention x is not this value, like they normally do, it doesn't affect the correctness of the problem. Does it not affect does it affect the correctness of the problem? Right. Let me check that actually, right? It's, if I wrote this correctly, then it's cosine x is, cosine's only going to be 1 when you're taking 0. That is an issue, right? Okay, so I suppose that is suppose the equality case can't really hold, right? 2 is an upper bound. Okay. Now I'm trusting the SMO problem most of the time by default. So if I'm now checking and seeing that x is actually negative 45 degrees, or something that cycles around, then technically this is undefined, right? That is straight. Okay, so arguably the question is then not correct. It's like supposed to be the best upper bound that you can achieve. Technically it is wrong. Are they going to consider that as wrong? I don't know, because the intended method is pretty clear, but none of the other answers are better. So we will see about this. I do not have any further ability to judge whether they would consider it as a voided question or do they consider it as just still 2. Okay, anyway, let us continue. As with the junior stream, we'll go up to question 10 before taking our first break. Because up to question 10, it is still within reach, I believe. Question 6 is nested cert, where you're not going to clear the nested cert, you're going to just square the whole thing as I've done once before in question 3. So, if you know that this kind of things you tend to mess up a lot, first of all, that just makes you normal. For 99% of people, when you've got nested anything, it is confusing. Just do it a bit slower to make sure you don't mess up. Okay. Shift over and divide by 2, square both sides. Again. This turns out to be linear, and so you get 15x equals to 64. I see no reason why this should be rejected this time because all the steps are reversible, but anyway, they did ask for 15x, so we are quite sure that this is going to be correct. Question 7. This is not an official SMS stream, so I can sometimes say a little bit less politically correct things. The grammar is not always very good. The grammar is not always very good, so their question, when they asked about such that this is true, they certainly should have added a clause. And the clause that they are trying to say is that such that this is 0 and x plus y is less than or equals to k. This really is meant to say such that if this, then x plus y is less than or equals to k. Okay, because x plus y could be less than or equals to 1, right? But I'm sure we don't mean that there exists x and y. Anyway, under this assumption, the standard way of doing it is to complete the square. To make it into this form. And then for the third or fourth time today already, we have got 2 options. First option is Cauchy-Schwarz. Just 1 squared plus 1 squared would do. Now this would give you 100 squared times 2, so 20,000 greater than or equals to x minus 100 plus y squared. You want to know the maximum value of x plus y. So x minus 100 plus y is at most square root of 20,000, which is 100 root 2, and so x plus y is less than or equals to 100 root 2 plus 100. You either need to know square root 2 to 2 decimal places, or you can also just shift it in as square root 20,000 and then calculate that to the nearest integer. Since I do know what is square root 2 to 2 decimal places, which is 1.4142, okay, just 1.41 would do, means that, okay, maybe I'll put a third decimal place. This is upper bounded by 241.4 approximately, so your k needs to be 242. This is option number 1. option number 2 is quad jump. Draw a circle. I mean, it is a circle. The circle should go through the origin just for the purpose of your drawing. And then you can say that x plus y equals to k should touch the circle. Not x plus y. The x plus y equals to this is going to your upper bound. Not k, because k is not an integer. X plus y is equal to some constant. And then it is quite clear that this will be 45 degrees, because x plus y equals to c means gradient is -1. And so 50 root 2, 50 root 2, this point here is going to be 100 plus 50 root 2, 50 root 2. And therefore your maximum is again the same result. Now I mentioned two methods that are not so-called similar to each other. There are still two more things that you can do for this. You can also use a discriminant method, meaning that let x plus y equals to c and check when are there real roots. You can also do a trigo substitution and then use the R formula. This kind of questions has appeared so many times in the SMO Senior and Open in recent years that the number of different methods that you can come up with, just pick your favorite one and it is likely to work. Yeah, some of you are saying calculus also, right? I'm not mentioning calculus here, but calculus is always an option. If you're comfortable with it, please feel free to use it. For round 1, nobody will know that you used it. For round 2, if you use it correctly, it's still fine. Just that you need to explain yourself properly, and that's good enough. Okay, question 8. Back to trigo again. Now I want you to look at every trigo question with a great deal of suspicion. Look at every trigo question with a great deal of suspicion, because whoever set the question, I didn't set any questions this year for the SMO. I set mock papers, so I saved my questions for mock papers. I didn't propose any questions here. But for whoever sets the questions, do you seriously think that they were one day sitting at their desk, they were doing something, or they were in the shower, or they were in bed, and then suddenly the guy just lied out and said, do you know that if cosine x over sine 3x minus sine x over cosine 3x minus 2 times sine 4x over cosine 6x equals to 24, then something nice happens to cosine 10x over sine 12x? I mean, nobody would think of random expressions just from thin air. It's built up bit by bit. You just have to reverse engineer how did the person come up with this. So there must be something nice. Otherwise, most trigo expressions, if you imagine just randomly generating coefficients, trigo functions, and arguments, nothing good's going to happen. So this is quite straightforward. Once you recognize what's nice about the numbers, you start off with combine these two. They are nice because of the fact that it's x and 3x, x and 3x. So don't open a triple angle. Just subtract the fractions. Now the top is going to be your cosine sum identity, and the bottom is half of your sine double angle. So you get 2 cosine 4x over sine 6x. And then you see it appears again. So if something worked the first time and you see it appear again, do it the second time. So combine again. There's a 2 on the outside, but otherwise it is the same. this is again the sum identity, and again half of your sine double angle, and so you get 4 cosine 10x over sine 12x. So bingo, that just means that this is 2024 over 4. Can see that like some people have just rage quitted the stream at some point. It's just like after some particularly annoying question, suddenly the number of viewers just boom, and after it comes back a while after people have calmed down. I know this is very painful, right? A lot of these are really very painful when you're like, wait, what? You will never forget. My experience is that any time where there was some question that I failed to do that was particularly costly, I never forgot, whether it be math or other things, but especially for math. I remember some questions that I did in primary school Olympiads up till now because I got it wrong. So it's a good learning experience. I know it's such a teacher speak to say that, but it's true. Don't blame you for rage quitting, but if you're listening to this, that means you haven't rage quit. That is good. Question 9 feels a little bit like the question I put in my mock paper, MCQ, on coefficients is not 0. This is like binomial theorem light. You don't need the full binomial theorem, you just need to understand what is going on. Now, the coefficient is not 0, just means some combination of x cubed and 1 over root x, which I like to put as x to the negative 0.5. Some combination of this is going to give you x to the k, where you have a total of 2024 things. So I like to think of it this way: the possible degrees, instead of writing full binomial theorem, maximum is all 2024, and then each time when you step downwards, you actually drop by 3.5. You drop by 3.5 each time. And actually we don't really care about the dropping 3.5 each time. We are just going to look at positive integer k. So I want to know integer possibilities. It's really just minus 7 that I care about. And therefore, since I started at 6072 and I can go down by 7 each time, I just need to take 6072 divided by 7. Remainder is 3, so the smallest number that you will land up is 3. That's your answer. Last one, question 10 before we go to break. This is not new. It's a question, this sort of question idea first came out in the AIME a few decades ago, and then it has been an occasional recurring theme in the SMO. I think as recently as 2017, there was one like that. If there was one more recent than that, I have forgotten. But the one that I think I remember is 2015 or 2017, maybe both. Anyway, long summations or long products, I'm very consistent in my messaging about this. Long products or summations, they are just going to be 3 main possible cases. Either there is a famous formula. If you are like, what famous formula? Then move on to number 2. Because you don't know one, so what's the point? So the second is that there is some way to group or pair stuff. And the third is there's some way to make things telescope. meaning cancel. Now this is true when you have a big chunk of things to add or a big chunk of things to multiply. It doesn't matter whether you put the sigma and pi notation around it, the logic doesn't change. So here there is a big chunk of stuff. 2025 is not really out of the pattern because it's just 2024 plus 1. So really what we just need to understand is how to collapse that big chunk on the left. And the question has provided a 1 over 2023. That cannot possibly affect the answer, but it's kind of a hint. You realize that for anyone who solved this, and 2 minutes later all of you will realize that 1 over 2023 doesn't need to be there, it won't change the answer at all. When you notice something in a question that doesn't change the answer, for example, in a geometry question, they created a redundant point for you. In an algebra question, they did a redundant term. They gave you a redundant term. It means that the SMO has decided to be a bit charitable for one particular small aspect of the question. Now, it is one more way in which you can discover that you should actually put the whole thing over 2023 and then put a factor of 2023 with all this other stuff. And 2023 is 2024 minus 1. So this is how the telescoping is going to handle. It's just repeatedly combined via difference of squares. So just keep on going, and you will end up with, at the end, the exponent keeps on doubling, i.e. the whole thing keeps squaring, until you're left with one higher than what was the previously largest one, minus 1 plus 1. It's gone. Now you do your log. Log base 2024 of 2024 to the power of this just cancels off. So you're left with this, and log 2024 of 2023 is something that is positive but less than 1, because log 2024 of 2024 would have been 1. 2 to the power of 11 is 2048, you just calculate it directly, and so this thing is equal to 2047 point something, and that pushes n back up to 2048. The SMO has a different coordinator for each section every year. They have a different coordinator for the SMO every year for each section, and what that means is that how do I put this? The style of the coordinator is a bit different. You'll see that in some of the years, they like a lot of floor functions. In fact, even the SMO Open, there's a lot of floors, right? So they will ask, okay, let the maximum value be m. What is floor of m? Or what is floor of 10m, right? So some of the coordinators use that style. Some of the coordinators like this style of smallest positive integer n such that n is bigger than this, and then they use this phrasing quite a number of times, right? Including like this question number 7, including even just question number 1. If you keep seeing this phrasing, each of these different phrasings all have the potential for off by 1 errors. So if you're not used to that phrasing that seems to be dominant in a particular SMO paper, you would like to just take a moment to think and make sure that you have not misinterpreted it, otherwise you're going to make the same error 4 times. Now I'm serious when you say that every single SMO paper has its own coordinator. If you don't believe me, just look at the SMO Junior and the SMO Senior. You'll see that the font size is different, even the font is different. You look at the SMO Senior paper that you have with you, you look at the page numbers at the bottom, they don't start from page 1. Everybody are doing their own thing in the Singapore Math Society. So honestly speaking, just make sure that you don't get tricked consistently by the same thing throughout the whole paper. Otherwise, that is truly very sad, and my condolences to anyone for which that has happened. Okay, we'll take our first break here for 5 minutes. If you have any questions, leave them in the chat. I'll probably just take a quick walk around, and I'll be back in a few minutes as well. For those of you who are joining in a bit late, what I mentioned at the start of this video about the cutoffs is that I am not certain, but my estimate would be something like this. I think that the round 2 cutoff could be in the vicinity of 12 to 13, all things remaining the same, which is not true because the number of qualifiers is discretionary up to the Singapore Math Society. And I still think that the boundaries below will look something like this, although that may change because again the Singapore Math Society doesn't officially publish the number or the percentage cutoffs for silver, bronze or honourable mention. So as far as we can tell, we're just going by recent statistics that the gaps are about 2 points to 3 points, often 3 points between round 2 and silver, and then 2 points below. So this is just my best educated guess. I also want to say that for any of you who are like disappointed, it's pretty hard to get a reliable score if, let's say, you are in that bronze range, because most likely if you're getting 8 on average, for example, over like a sequence of 5 papers, you're going to get everything between 5 marks and 11 marks, depending on the type of questions, whether you're familiar, careless mistakes, computational errors, and so on. So one particular performance is always going to, sometimes you get better than you expected, sometimes you get worse. Now, the SMO is already over, so anyone who is watching this in 2024 now, you are watching this with plenty of time to go to the next year's SMO. If you're taking any section, whether it be you're taking senior for the first time next year, senior for the second time next year, or just open, you want to aim for like a few marks above whatever your target award is, because that's what allows you to reliably get that award. Just like if on average it takes you 30 minutes to get to school, you don't leave 30 minutes before school starts. The other thing is geometry, right? And so this year's paper is unique because of problem distribution, especially now that we go past question 10. It's where all the weirdness starts. There is a lot of geometry. There is a lot of number theory that will come in the final section. And this is not the normal problem distribution. If you are not so comfortable with geometry, then that is unfortunate. But what you want to do is always to sort of try to think whether a purely algebraic methods can work. Right? You want to think about, is it possible to consistently use algebra from the start to the end? If you can, just use algebra if your geometry is not good. When I say algebra, that includes trigonometry. Now, if you look at the question and say that, no, the algebra is too horrible, that means you're missing something geometric. And then look at what is the nicest aspect of the question and think whether you have missed any good geometric feature. So if you don't notice anything first, just ask, do I just do algebra? For example here, okay? So let ABC be a triangle with area 1000. Let M and N be points on AB and AC respectively, such that AM to MB is 3:2 and AN to NC is 7:3. Now let X and Y be the midpoints of BN and CN respectively. Find the area of AXY. Now we would be able, so just by using ratios of areas, what can we find? We can find A and B, and we can find B and C. We can find AMC and BMC, right? That's what it immediately gives us. Now, based on that, A and B being split in half at the point X being the midpoint, you could find ABX and ANX. Point. You could also then find BXC. You could find CXN, you could find, you get the point here. I'm just writing all this out to say that none of these things are AXY, and none of these things easily give you AXY. This is normally how I do geometry. Either last time as a student, probably I wrote it out. Now as a teacher, I just think about what can be found easily. Now don't go and find them. Think about what can be found easily and ask yourself whether those things can give you what you're asked to find. And if the answer is no, you've probably missed something important. Now, X and Y are the midpoints of BN and CM. Every time I see something like this, I just believe there is something significant about it. The significance here would come from the fact that MX and NY, like, what's nice about them? If X and Y are midpoints. Now, the answer is that very often midpoints want friends. Equal stuff, the more you have, the better. This is also true for equal angles, pairs of right angles. When you've got two right angles, you either get similar triangles or cyclic quadrilaterals. Equal angles means parallel lines, cyclic quadrilaterals, or isosceles triangles. More than one midpoint usually means you get parallel lines, except that here they are the midpoints of two unlikely things, two unhelpful things, Bn and Cm. So I'm just going to plonk in a third midpoint. Let's call this point P. Give them a friend. Now X now has a friend. They are both midpoints in B and C. Y also has a friend. From Y's perspective, they are both midpoints in BCM. So this is good. Now this is good because we are now able to find quite a lot of things. Specifically, I have already listed out some of the things that we can find just now. I've said that I can find ABX. I have not yet finished listing the thing just now because I got irritated, but we can also find AYC. So I'm going to just start shading all the things that we can find. Now BXP is 1/4 of BNC, right, because of your midpoint theorem. So one more thing that I can get is BXP. I can also get CYP. So that is pretty good. Now, can you find PXY as well? Is the question. Okay, so as we are doing this, now that I will just start writing down all the values. I haven't done a single computation yet, and so if I haven't done a single computation, obviously no numbers have shown up. But I can start looking around. Okay, so this is 3:2, this is 7:3. 7:3 means that A and B is total area is 1000, so this is 700 and 300, this is 600 and 400. ABX is half of that. ACY is half of that. BXP is 1/4 of that. And CYP is 1/4 of that. Yeah. So the last thing is, can I find PXY? And PXY is special because of the fact that it has two parallel lines which are parallel to the sides. But the third side, XY, is not parallel to BC, otherwise they would just be directly similar. In order to finish it off, I just extend out here and I extend out here. So you have got a parallelogram at this point. Yes, I'm going through this very slowly, right? Now, if you're thinking, but we've got so much time to do this in the SMO, two things. First of all, for the more experienced students, half of this is muscle memory. You're not going to actually think very hard. The other thing that is true is that a lot of you ran out of questions to do, right? So, I mean, that doing something slowly is better than not doing anything at all. Okay, so the last thing to kind of mention is that whenever you have these sorts of things, diagrams, especially for round 2, right? Some of you are asking about round 2. For round 1 and round 2 is the same thing in one aspect, which is that our brains are not able to cope with complicated diagrams. So just take out small little pieces to work with. Now I found a parallelogram, and for the parallelogram, I kind of know a lot of things about it. So I'm just going to draw that. Parallelogram, not a very nice one, but it's okay. Now, your x and y are somewhere here. This ratio is going to be the 7:3 transferred over to here, which means my diagram is not very good. This ratio is going to the 3:2 transferred over here. So that means that all you need to do is to find out this triangle's area. It's related to the parallelogram. By, I didn't name these 2 points. Let's call them E and F. So PXY is equal to 2/5 times 3/10 which is as such. And then of course PEF, E and F are midpoints of the triangle. So PEF is just 1/4 of 1000. So that's 30. And now I have just got lots of puzzle pieces that I am subtracting off from the total. Okay, so I'll leave the subtraction to you. You've spent long enough on this question, but that will be your answer. I'm going slow on the geometry because the geometry is sort of not easy, but you have a chance. If you are honest, none of these things are complicated in geometry theorems. They are complicated in just observations. Oops, sorry. Now, in contrast, you have got this thing here that is just, in question 12, just a Pell's equation. If you do not know what's a Pell's equation, I'm sorry, you do not really have any realistic chance of doing it. So there are questions that are completely the opposite. So you must look for questions that you can think about, because you cannot think out this thing if you do not know what is a Pell's equation. So, what is Pell's equation? Pell's equation is anything in the form x squared minus dy squared equals to 1, where d is not a square. The solution for Pell's equation is just a fixed algorithm. Now, if you do not know the fixed algorithm, your chances were slim. Let me just tell you what is the fixed algorithm. Step 1, find a simple solution. And by simple, simple means the smallest solution which are positive integers. This is easy for 2024 because that would be x is 45, n is 1. The last time there was a Pell's equation in the SMO senior, I think, was 2019 Q25. It has appeared in SMO open since, but senior, if I'm not mistaken, my memory is a bit hazy what senior and open. So if you do not know what Pell's equation solution is, I'm explaining it now. If you're asking why, that's not what I'm explaining. Okay, I'm not explaining why. The proof would take far longer. So step 2 is that your solutions are in the form xk, nk, where, and this is the part where you would not be able to actually just generate it from scratch. Yeah, in the form of this, the 45 is this 45. The 1 is an invisible coefficient, and the 2024s are all this stuff. If you don't know it, you don't know it. Someone would like to share how you can get it, otherwise let me know, but I think there is just no alternatives. Okay, so question is largest positive integer n less than or equals to 10,000. There are actually infinitely many values. So if you took k equals to 2, you get (4049) plus 90 root 2024. So that means that your second solution that also works would have been 4049 and 90. But that's not going to be the biggest n that you can possibly find. If you go to the next one, yeah, I don't like this as well. Qubit means multiply this. Good news is that n is the coefficient of the square root. So I don't need to calculate the x, I just calculate the n, which comes from this and this times 1. So answer is 8099. This is a very important and good time to highlight how the SMO is not in order of difficulty. The SMO in this year for the senior seems to have, again, in relative terms, be like a sandwich. Easier start, a very hard middle, and an easier end. Relative terms, okay? I'm not saying that the start is super easy and the end is super easy, but comparatively speaking, the middle is hard. There have also been times where the start and end are really hard and the middle is quite simple. Question 13 is 3D geom, and the diagram they have given is not very helpful. Because of the diagram, the first thing I tried to do was a bunch of algebra. I'm not going to show you the bunch of algebra. The reason why I'm not going to show the bunch of algebra is that it is just, it doesn't work. So once it didn't work, I was looking at it and saying, nah, this cannot be that hard. It feels offensive. This cannot be as hard as the algebra I was looking at. This is also not the SMO open. It doesn't need vectors. And so soon I realized a couple of things. Right. I'm going to try to highlight the equal stuff. SB equals to SC. But this is 60 degrees. And so actually, it's equilateral. Okay. At least this one thing in their diagram seems believable. Now, the other thing is a bit harder to mark out in a 2D rendering, but because of the other 60-degree angles, what I realized is that actually your triangle ASB is congruent to triangle ASC. It's just a rotation. SAS, yes. Now what that means is that the other angles being equal are fairly useless, but these two very unequal looking angles, lengths, are actually equal to each other. So this is not such a horrible tetrahedron. This is a relatively okay tetrahedron. Now, of course, there's also the 90 degrees. Now, the 90 degrees is just simply going to tell you that if I take ABC as the base, right, we know that volume equals to 1/3 times base area times height for a pyramid. A tetrahedron is just a triangular pyramid. Then the height would come down here, and the height in an equilateral triangle is probably one of the few things in this paper where it is actually easy to do as a geometry task, or even if it's just sine 30 degrees. So it's √3 over 2 times this is 2 √3. Height's not so bad. These are all known. The only thing I need is base area, and as an isosceles triangle, it would mean that this is actually perpendicular both ways, but the one that I want is the base. So I'm going to call this thing here, I don't want to call it height. It's the height of the base face, but to avoid any confusion, I am just going to call this thing x. At this point, I can find everything. This is square root of x squared plus 12 by Pythagoras on ASM. This is square root of x squared plus 4 by Pythagoras on AMB. And then the only information that we haven't actually used is that the other two blue angles are 60 degrees. We have used the fact they are equal, but not the fact that they are equal to 60 degrees. So cosine rule to end off. On ASB or ASC is the same thing. Okay, so this one, just the x squared just cancels out, so it is fairly easy to solve and get x squared equals to 24. So I'm going to just go with that. And so x equals to 2√6. And so base area is half times 4 times 2√6. Lots of stuff cancel out all over the place, but when you simplify this, you get 8 square root 2. And the question asks you for the square of the volume. So you square that. I've told a long time, I've told a lot of students for a long time that, oh, 3D geometry is just an American thing. It just shows up in the AMC. Don't worry, the SMO does not have 3D geometry because our Singapore problem setters are not good at setting interesting 3D geometry questions. Clearly, I was wrong. At this point, I think we can stop saying what the SMO does or does not test. But what I can say is that generally for 3D geometry, you don't solve it as 3D geometry, apart from like volume formulas and surface area formulas. Everything else is about cross sections. You draw lots of triangles and circles, not work in 3D. And don't worry about vectors. Famous last words, but I trust that vectors are not going to show up in the SMO Senior anytime soon. This is a hard middle section. 14 is not much better. In terms of obviousness, definitely not. I feel I've asked a question like this in one of my classes. I cannot even put a finger where. It's either one of my mock papers or it's my AMC, one of my AMC lessons, because this is pretty, again, unusual for the SMO to ask Vietas in such a non-obvious way. Vietas does tell you that sum of roots is 2, sum of pairwise products is negative 21 over 2, and the product of roots is 4. So this is what we have for now. Right? So negative of minus 4 over 2, just minus 21 over 2, and negative of minus 8 over 2. It does not look like this has anything to do with Vietas. My sympathies to any of you who tried to expand out all of these fractions by actually forming a common denominator. In general, before you do something, please think about whether it's going to go well, right? It's not about how bad it is it even useful to do that? There's a saying, right? Cut off your own nose to spite your own face. If you're getting very angry with the SMO at this point for why have they come up with such a hard paper, first of all, you should be more angry with the SJPO organizers. But second of all, don't torture yourself because you're angry with the SMO. Just give the question if what you're going to do is to combine them. However, what I would do is that I know AB is related to C by being like 4 over C and so on. So I'm going to just multiply the top and bottom of the first one by C, so that ABC is 4. So the whole thing is just an expression in terms of C, and I will do this symmetrically for the other two as well. Now I look at this and say, what does C squared minus C plus 4 have to do with the cubic? The answer is, I don't know, but it better have something to do with it, otherwise I'm in a lot of trouble. What does it have to do with it? I really don't know, but it had better. And so my idea now is that I'm going to look at all of these, which are x squared minus x plus 4, right, in the form of this. And I'm going to look at this 2x cubed minus 4x squared minus 21x minus 8. Remember, this is true, of course, when x equals to a, b, or c. That's the meaning of roots. And what I'm going to do with this, which perhaps makes no sense, is I put them in this way because I'm prepping long division. Now, what exactly am I hoping to accomplish from this? Let me be honest, I said a question like this before, or at least I saw a question like this before, so I have no idea like how I would have thought of it if I had not seen or encountered something like this before. But here we go, long division. The saving grace is that a long division is not very long. I better not make a mistake, otherwise that will be very embarrassing after I just said the long division is not very long. We're done with the long division. What is the point of that? Well, the point of that is, let's write down what we have just discovered. Now, for x being a root, the left hand side is 0. This means that the right hand side is 0. Remember what we're trying to find. We're trying to find things of the form x over x squared minus x plus 4, where x is a, b, and c. This is what we wanted. Is it clear what's happened? Definitely prefer to sum that. So I can add this up over ABC. More people are rage quitting. So 2 over 31 is the common factor, and then sum of x minus 1 and then finally in goes the Vietas. By now I've forgotten what a plus b plus c is. What is it again? It's 2. Okay, numerical answer 965. It's exhausting, right? Next up comes a trigo. This is really like a gauntlet. But question 15, thankfully for me, looks familiar. This is one time where I don't think I needed the question to look familiar, because what I found familiar are the values root 3 minus 1 and root 3 plus 1. It doesn't mean anything to you, however, the question is still not impossible. The question is not impossible because when we do these sorts of trigo-based problems, I just want to get into the general vicinity of my identities. My general vicinity of identities definition is just that there are lots of different ways to combine sine and cosine. So I'm just going to clear the denominators, multiply everything by sine x cos x. And then essentially the left hand side, I can combine it into a sine of something by our formula. The right hand side, I can combine into a sine double angle by the sine double angle formula. And so I can move over 2 root 2 to this side. Because if you are one of those weird math people like me, recognize that this is sine 15 degrees and cosine 15 degrees. If you are not weird math people like me, you just use the R formula. And for the R formula, you would end up needing to recognize that tangent inverse of 2 minus root 3 is 15 degrees, which is still weird, right? So you have to recognize some 15 degree thing. But 2 minus root 3 is slightly less ugly than this. That means that whether you use the R formula or you just are weird like me and recognize these values, you can combine them in this way. Sine x plus 15 degrees is sine 2x. I use degrees for now. If you want to use radians straight away, you can use radians, but I think most of you would prefer degrees for the most part. Okay. 0 to pi over 2, this is first quadrant, but x plus 15 and 2x can go up to the second quadrant. So we know that for first and second quadrants, sine can be equal if they are literally the same angle, or if they are supplementary, they add up to 180. So x is 15 degrees or 55 degrees. The sum is 70 degrees, and of course conversion rate to radians is pi over 180, and so your answer is 25. Question 16. This is not actually 3D geometry. They just had a very exotic way of trying to force out an integer answer. But it's a circle geometry question, and then they just decided to ask you what's the minimum possible distance of any point on PB to the top of the tower. The tower has height 20. But still the nearest location is going to be the perpendicular. So you definitely draw the perpendicular. Remember, this is a circle, so these two are going to be equal. And essentially, the question is asking you what is this length. I'll call this point M. I'll call this point N. Now, because they're asking for that length, you can kind of ignore that entirely, and you're just looking for what's the length of OM and then Pythagoras at the end. Minimum possible distance, now you can ignore, you are just finding OM. This is now a pure geometry question. We put every information that we can use numerically down. PB is 33, PC is 77, and CD is 74. This is 37, 37, and this is 3. Now, immediately I just say that there is one quick length that I can find, which is using my power of a point / intersecting sequence theorem. Of course, this gives you Pn equals to 7. This length Bn here is 26. And so all the RI students here know surely who has proposed this question. Doesn't matter anyway, because we are basically done. This is 13. This is still the radius, it's 37. Sorry, no square. Right. So OM squared is 1200, and then you go to this distance, which is 40. I'm getting out of breath, so let's do one more question and then we'll take a break. Because I do not want to open up the third segment of our discussion on question 17. Question 17 is just, do you know the shooting lemma? Do you know the angle bisector theorem? Do you know homothety? Now, all of these things, if you do not know, it is just way too much work. There was a question, I think, in the 2019 SMO Open that was something similar to this. Okay, what are the statements? Now, the first statement, which is that if you have a chord and then you squish a circle into that segment, the 2 points of tangency is called the shooting lemma, because if you shoot it out, where does it land? It lands at the midpoint of the opposite arc, a fancy way of saying that this is going to be an angle bisector. The second thing is that, so this is called the shooting lemma. The second thing is homothety, which is that you can scale between two similar shapes, such as circles. Just imagine that you are scaling up from P. Now, when you are scaling up from there, all the corresponding points, right? I guess geography students can think of this as some Mercator projections or something. Someone's going to tell me I'm wrong. The corresponding points, they're all going to get blown up by the same ratio, and more importantly, it is going to also be parallel. And so the two implications, therefore, are one, that this is an angle bisector, and two, that the 2:3 ratio is going to also extend out to PB over PA. And the angle bisector theorem tells you that PB over PA equals to CB over CA. So this is homothety, this is your angle bisector theorem. And the angle bisector theorem, the angle bisector came from the shooting lemma. This is way too many names, right? So if none of these sound familiar to you, this would not have been a very likely question. I also think it's not very drawn to scale, so if you guessed it, good for you. Otherwise, if you guessed it, probably you at least know one of these. You're thinking of the angle bisector theorem. So the angle bisector theorem tells you CB to CA is 2:3, so CA is 3/5 of 15 equals to 9. Everyone needs a break now, right? So let's take 5 minutes. You can argue, you can moan about whether this is way too hard to be an SMO senior paper. You can continue to describe how the SMO open paper was so much easier than this. Whatever you feel like doing, I'll be back in 5 minutes. finish typing question 8. Sorry. Let me finish typing the question. Okay. Question 18, I mean. Right, we are on the last 8 questions for our final segment. Last 8 questions is dominated by appearances of number theory and trigo again. Now, in response to some of the things that you guys are talking about for preparation for the SMO, I think that there's a lot of we are saying the word prepare in too vague a fashion. You see, like how you prepare for the SMO 1 year in advance, how you prepare for the SMO 1 month in advance, and how you prepare for the SMO the night before are quite different. Someone's definitely watching this the night before the SMO 2025. But if you're preparing a year in advance, it means that you don't look at the past SMO papers as being like, I remember the solutions to these questions. I just practice math in general. That includes your AMCs, AIMEs, your SMO is one of them, of course. That includes if you use contests from other countries. That includes also if you are you're familiar, there are lots of online contests on Olympiads as well. Some of you are on AOPS, you just go into the forum and you try some random questions. Right? That's like a year. And of course you learn some things because our school syllabus only really has the algebra part as well as basic geometry, basic at least compared to these questions, right? So the rest of it, like number theory and combi, are barely going to be in school syllabus. This is entirely Olympiad based. If you're 1 month out from the SMO, that's where you start looking at the past SMO questions because even though the papers do not look like the previous year's papers, they do share the features of the previous 10 years papers, for example. So 1 month out of the SMO, that's what you can do. And then the night before the SMO, you're just hoping you don't forget some formula. So some of you looked at the crash course video, that's the purpose of it, right? It's not going to solve your all your preparation needs. It's meant for like the day before or 2 days before. Alright, so let's come back. Question 18 is a weird one. It's weird because it is literally in my mock paper for my Sec 3 students, except that I said this question like 5 or 6 years ago, and I suspect it may not have been original. I suspect it may not have been original means I said it a number of years ago, potentially having seen it as a student, but I don't remember where. So it could have been from an OSMO, it could have been from an American contest, I am not sure. But it is a classic question, and I have posed it before as well. The idea is that this is a huge pile of words, but each vertex, the product of the numbers written on the faces, is going to be the number that you assign to it. I want you to think of how you would describe a vertex. So how would you describe a vertex of a cube? Let's say, for example, you are thinking of this cube and you're trying to refer to this one. Those of you who do speed cubing, right? Rubik's Cube, speed cubing, you know that the algorithms are described using, this is left and right, top and bottom, and front and back. Now, because of the fact that these are both B's, the Rubik's Cube, they changed the name to be something else, but we're not doing cubing here, so I'm just going to spell them out literally, right? There is left or right, and there is front or back, and then there are top and bottom. So this collectively, there's 2 of this, left, right, front, back, and top, bottom, describe the 8 different vertices. And then the faces themselves, this left, right, front, back, top, and bottom have values associated with them. More than 2. Now, 2024 is the sum of all of these different combinations of products. So I am going to put it to you that what this statement becomes is just this. This is what it is. If you expand this out, the expansion literally is the description of the 8 vertices, and the description is the calculation if I literally name the faces left, right, front, back, top and bottom. If you do programming, I'm sure that you would prefer to have your variables, if you're reading someone's code, to be called top and bottom rather than A, B, C, D, E, F. So I do the same in math sometimes. I spell out a word as a variable name. It's one thing you can import from those of you with NOI experience. Use variable names. They don't have to be A, B, C, D, E, F whenever you are doing this kind of word problems. Okay, now we finally get to use our factorization of 2024, hurrah! And we need to split it up into 3 factors where they are greater than 2, so each of them has to be more than or equal to 6. The only way that can happen is 8, 11 and 23 or some other rearrangement. You want the maximum possible value of an edge. The edge is the product of 2 numbers in 2 adjacent faces. So it cannot be in the same pair, so it's not top and bottom multiplied together. It can be any of the other combinations, so the best way you can do it is just to make one block of them very small, which as small as possible is 3. The rest of them can be big, and then you pick the 2 biggest ones to multiply together. Okay, so it's called up and down for cubing. Yes, so you can tell that I have not been doing any cubing for a very long time. Well, that's fine then. Yeah, actually now that definitely sounds right. Okay, so this is your the same reasoning for how you calculate the sum of factors of a number, right? The sum of factors is that when you take the prime factorization, you're like, okay, it's 2 to the 0 or 1 or 2 or 3. That's the first bracket. And then 3 to the 0 or 1 or 2 or 3 or 4 or 5, then you put it in a bracket. Basically, all translates to plus and n translates to times. This is also true of your logic gates in Boolean algebra for programming. It is certainly true in this case as well. Question 19. Floor functions. First thing to do is to ignore the floor function when you're looking for integer solutions. So the integer solutions would be, if it's an integer, I can factor it. That's not all, right? This is just integer solutions are here. Now, what I can say therefore is that we can just go with the manual listing out the cases of floor X approach. We could technically bound, but that's not very necessary. What I want to do is just to kind of draw a table. Floor X, based on the trial of floor X, when will X squared have a chance of being equal to 4 times floor X plus 12? Now, I will just start from the -2 all the way to 6. If there's anything outside of it, we are going to find out in a little while. Now, what exactly am I trying to do here? Now, 4 times floor X plus 12. By drawing a table, all I'm doing is writing a whole bunch of multiples of 4. So surely this cannot be a very hard task to do. Now, when we say that the floor is -2, it means that it is actually from -2 to -1, excluding -1. Now, that allows me to talk about a range of values, which is, this is 1 to 4, This is 0 to 1. And then this will also be 0 to 1, and then it just goes up through your square numbers. Now I'm just writing this down very explicitly. There are ways that you can bound it more carefully, but this is the kind of question that in a desperate situation of a hard SMO, I would definitely jump at just writing some stuff down. Apart from giving me an extra mark, it allows my brain to stop hurting so much. Right? This doesn't hurt the brain as much. Now this one here is just the x equals to -2 and x equals to 6, which we expected already, so that's not news. But there is another place where they intersect, which is down here. So they intersect at this location. X could be just square root 32 in order for them to meet. It is quite easy to see that beyond this, the x squared is going to be very far away from the floor x plus 12. Specifically, it's going to be bigger than 4 floor x plus 12 beyond this, and so therefore you don't really need to look anymore. So floor function questions, remember that it now allows you to consider cases because you are working with integers. If I know that I'm looking between 6 and -2 in real numbers, I can't really list, but the floor is an integer, so in that sense I can list. Question 20. Step 1, factorize 1216. Now, when you want to do number theory, many number theory questions are find the remainder when this is divided by this, or when is this divisible by this. If the this is an integer, you want to prime factorize it first. Fast forwarding a lot, the prime factorization is 2 to the power of 6 times 19, and I would have a tiny little celebration when I see 19, because obviously mod 19, this is just 1. So I'm left with the mod 64. I don't know how good or bad mod 64 is at this specific juncture. So I will first just reduce down the 1901. 29, remainder 45. I think I'll go to -19, so that's a little bit smaller. Okay, now if you used Euler's theorem, for those of you who know Euler's theorem, you would conclude that 19 to the power of phi of 64 is congruent to 1 mod 64. Now if you use that, phi of 64 is 32. I'm not going to explain the phi function for now, it's a bit hard to do here. Just Google Euler's theorem if you are not familiar with it yet. Anyway, I'm trying to say that it has limitations. So if you concluded this, what you will need to do is do 2024 divided by 32, and you would end up with a remainder of 8. Right, so every 32 you can throw out. There's a remainder of 8, and so this will be congruent to 19 to the power of 8. And then the only thing you can really do is just repeated squaring and take the mod. So this is the Euler's theorem approach. Square, reduce, square, reduce, square again, and then reduce. So this is if you use Euler's theorem. It is not wrong. In fact, I I suspect it may be the intended approach, but I'm saying that it will not be instant. It has limitations in the sense that you still need to do this computation. That's how Euler's theorem is. It shrinks it down, but not necessarily all the way. So if you are working with your Euler's theorem, and you got this, you would be able to combine it, but I'll just hold a second and mention about an alternative, which is the binomial theorem. Now, the binomial theorem does not require you to know very much in comparison. Why the binomial theorem is viable is that if I expand from the 1, this already contains 2 to the power of 4, and this will contain 2 squared. So this is already divisible by 64, which is 2 to the power of 6, and so is everything henceforth. They would therefore disappear mod 64, and so this one is quite easy to compute by comparison. You will still end up with 33 mod 64, of course. Last step is to put them together again. And technically, the Chinese remainder theorem is what gives you permission to put them together again. 1 mod 19 and 33 mod 64. But how you actually do it will depend on what is nice about those values. Like you can, in the default situation, just keep on listing out 33 mod 64 things until it is 1 mod 19. But then I realized that this is 2 times 32, and 33 mod 32 is just 1 mod 32. So I can combine this first, sort of halfway there. 1 mod 19 and 1 mod 32 would give me 1 mod, their product, which is 608. 1 mod 608. So 1 is not the remainder, otherwise it would have been 1 mod 64. But this means it's 1 mod 1216 or 609 mod 1216. And you can check that this one is indeed 33 mod 64. So that is our answer. This requires you to be quite conversant in modular arithmetic. So if you're asking me about one specific step, well, I think everyone will be able to help you. But if you're asking about every single step, then again, this question, you're not quite ready to attempt it. If you're looking for a pattern, this would probably take far too long. Question 21. Let Px be this polynomial with non-negative coefficients satisfying ai is between 0 and 17 for all I. If P18 is this thing, find the value of P of 3. Important to note is that all of the coefficients are integers between 0 and 17. Basically, yeah, that's a pun. Basically, this is meant to be solved as base 18. You don't need to solve it as base 18, but the way that you would do it is tantamount to that. Because if I were to say that this is actually 367616 equals to A0 plus A1 times 18 plus A2 times 18 squared plus an times 18 to the power n. This is literally the meaning of the number, this thing in base 18. That's what it means. I'm not saying that you need to use the knowledge, unlike some of the things you've said earlier, which I said you have to know. This one, you don't need to know that. However, for those of you who already are familiar with how bases work, it could help in your intuition. Now the reason why it would help in your intuition is that you know that there are two different ways that we can convert a base 10 number into a base something else number, which is either top down or bottom up. Now the bottom up approach is to sort of start from A0. Now you see that everything here is multiples of 18, so A0 is just going to be this thing mod 18. You divide this by 18, which I am going to just write at the side. 2, 0, 4, 2, 3, remainder 2. So that means that this is 2. After that, once this is 2, you subtract and divide by 18. So I need this. Basically, I'm going to be left with 20423 equals to A1 plus A2 times 18 plus A3 times 18 squared and so on. So that's why I kept the remainder and the quotient, because now you take 20423 mod 18 and one more division again. This equals to 113. I lost track of where I was at. 1134 remainder 11, which means that the second digit is kind of like 11, or if you actually are familiar with base 18, you know it will be called B. But we just use 11 because it's still a polynomial after all. And then after that, you repeat one more time. Not one more time, right? But it's getting faster. We're getting to smaller numbers, so this is just going to be 63 remainder 0. So likewise, following this pattern, A2 is going to be 0. 63 divided by 18 is 3 remainder 9. And so A3 is 9, A4 is 3. So it will be this, and then you compute it back. Okay, and the numerical answer for this will be 521. Now the top-down direction would be to just first start calculating powers of 18. I did not feel like doing this because I didn't use this approach, and so I don't actually know what is 18 to the power of 4, but I guess I shall calculate 18 to the power of 4. I will use a calculator. My brain is too tired to do mental 4-digit times 2-digit calculations or to square 324 at this point. So I was missing a digit. Okay, 104976. So if this is your bunch of values, then you kind of apply a greedy algorithm and say, how many of these can I take each time? So starting from the 367616, I can take 3 of this. Get 5, 2. It's not very fun to watch people do division, right? So that's why I was trying to avoid this. But then after that, you will divide this off. If you divide this off, you will find that there are 9 of it. So you do long division, yes. To find this 3, it's basically long division. I'm just writing it in this way to kind of show what's going on. You can kind of estimate that 9 copies of this fit here, 3 copies fit here. So that is what I'm doing. 2, 4, 8, so that's a relief. It shrinks down all the way to 200, so I cannot take any of this. I take 11 of this and 2 of that. So you see that again 2, 11, 0, 9 and 3 will show up in a second way. Okay, so these are your 2 choices, either top down or bottom up. Okay, question 22. Now I feel that in a normal SMO year, and I think some of you caught on, right? In a normal SMO year, something like this could have just appeared as a question 8 and many of you would have solved it. It's just that by now, if you're doing it in some sort of sequence, you will be fairly fed up and have given up. So yeah, the previous one, the answer is 521, right? I just showed a second way of getting the polynomial, but answer is 521. That's your P of 3. So as I was saying about this, it's not that hard. But the pi over 260s and all this a bit annoying. Still, just recognize that I mentioned about the different ways of summing, right? I said famous formula, grouping or telescoping. I don't know how to make 2 over 1 plus tangent something lead to a telescoping sum. But these angles sum to pi over 2. Which is 90 degrees, so I suspect that it should be something special. And the reason why I suspect it's something special is that tangent x versus tangent 90 minus x. Now, here's something cool that you may not have known, right? All your trigo 6 identities, sorry, 6 functions, sine, cosine, tangent, cosecant, secant, cotangent, all the cos stand for complementary. In other words, tangent 90 degrees minus x and cotangent x are the same thing. So this is a simple way to remember why these two things are reciprocals of each other. Although you could surely also have drawn a right angled triangle. Therefore, each of these pairs looks like 2 over 1 plus something, I'll call it y, and 1 over y. Clear the denominator by multiplying by y and you will see that this is nice. It's probably the shortest question we've done in a fair amount of time, so each pair sums to 2. Now when each pair sums to 2, you should always just do a quick check of the thing in the middle if there's an odd number of terms. Just to make sure that it's not an exception, because the SMO can be mean and find a way to make the middle an exception. The middle is this, but thankfully that's just pi over 4, and pi over 4 is 45 degrees, so tangent 45 is 1. So confirms the middle is 1, and so you can really take it as each pair gives you 2, each one gives you 1, and so your answer is 129. Question 23. An equilateral triangle ABC is inscribed in a circle. P is a point on the minor arc BC. Point D is the intersection of AP and BC. You have got 5 and 20, and you're supposed to find AD. The first thing that I want to do is to just mark out all the 60-degree angles. I don't really need to, but I can. So I shall. These are also 60 degrees by your angles in the same segment, right? These two are equal to each other. These two are equal to each other. So I just mark all the 60-degree angles I see everywhere. And that will give me relatively more options for what I want to do. Now this is potentially the easiest or second easiest geometry question in the paper, in my opinion, because it's not much geometry. You can just use trigo if you want, and I'm sure some of you much prefer to do trigo. I can find all the side lengths of the equilateral triangle by finding one side length, and I can find one side length by just using the cosine rule on this thing. This is 120 degrees, so cosine 120 degrees is minus half. Do I feel like simplifying it? I shall simplify it to 5 root 21. Now remember that what you're trying to find here is AD. So there are kind of a lot of things you can do here. When I say there are quite a lot of things that you can do here, let me name a few. And you do not need all of these, but I'm just throwing out all of the things. First thing you can say is that your angle bisector theorem would give you BD over DC equals to BP over PC, which is 1:4. So this would imply that BD is root 21, DC is 4 root 21. If you got the value of BD, you can immediately get the value of AD. Either cosine rule again, which I'm a bit lazy to do, you can do it yourself, or you can also use the fact that your triangles are similar, BDP and ADC. Sorry, C is covered by my angle, B is also a bit covered by my angle. And these two are similar to each other, and so therefore AD to BD equals to AC to BP, which is going to be 5 root 21 over 5. So root 21, and this gives you AD is 21. That's an option. Another side direction that you could have taken is, well, of course you have used cosine rule on the other side. You could also have noted from Ptolemy's theorem. You're scared of the word theorem by now, right? So there is Ptolemy's theorem, which is that if you have a cyclic quadrilateral, first pair of opposite sides, second pair of opposite sides, sum of products is the product of the two diagonals. If you want to try to show this, you can try to show this using trigonometry. It is the same kind of logic as a lot of other trigo things if you want to prove it. However, you really want to use it in this case because if you started here without even knowing what the sides of the equilateral triangle are, these cancel out because they're the same. So this would have immediately given you AP is 25, in which case you could also have used the similar triangle ABP and ADB. Somewhere down here you could also have used power of a point / intersecting chords theorem. Your AD times DP equals to BD times DC. So basically that's a lot. But why I think this question is not so bad is just the sheer number of options. If there is a way to just find every length one by one, then do that. A lot of the earlier questions that we found harder is because I can't find every length one by one. And so if we contrast with the earlier questions on geometry, for example, this one, we couldn't find the lengths one by one. We needed to know a property. So that's not easy. For this one, we could find the lengths one by one, so it is a little bit easier. For that tetrahedron, we couldn't really find the lengths one by one, so that is maybe not so easy. And certainly for that big chunk of an area thing, we couldn't find the lengths, and so it was a bit trickier because this AXY is very inaccessible. In other words, thing number one to try for geometry questions is, can I find everything one by one? As I said just now, just plan out what you can find first. If you can find them, then fine. If you cannot find, then don't start finding unless you have ran out of things to do. Right? Do something else first if you are going to just bash trigo aimlessly. Question 24 is also not difficult compared to the earlier number theory question. This is easier than question 20. It's easier because, first of all, the 95 and 96 is a lot more explicitly clear in terms of how they're related. They differ by 1. So you move this over. Congruent to 0 just means it's divisible. So I write it like this. I factor it. But I'm going to just drop the modular arithmetic thing in a second and just say that it means that this is a multiple of 96. Which is 32 and 3. A quick note to those of you who have a bit less experience with this kind of modulo splitting. Please remember that when you're splitting them up, you don't split because there is a divisibility test. You split into stuff that are co-prime. Right? If I split up this 2 to the 5 into 5 twos, I cannot ask whether is this even, 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 and therefore I know whether it's a multiple of 32. I can only split it like this. So now, time to think about what is going to happen. Now, for mod 3, anything that is like small, I'll just test every possibility. So if x is congruent to 1, 1 cubed minus 1 is 0, okay. 2 cubed minus 1, mod 3, not okay. 0, definitely not okay. So x is 1 mod 3 is condition number 1. I don't want to test for 32 because that will require me to test a lot of things. So thankfully, I realized that for x squared plus x plus 1 is always odd. So if it is always odd, it offers no help in helping you to make it divisible by 32. And so therefore, it tells you that the x minus 1 is a multiple of 32, and so x is congruent to 1 mod 32. It's also congruent to 1 mod 3, so for once, not a big problem. We just have x is 1 mod their product, which is 96. And now you just count how many you can fit in below 9,000. Remainder, I forgot what, but certainly it can only just fit 94 things. Yeah, thank you. Yeah, it's a remainder 72, and so you're going to get the list of things that work. It starts from 1, and then after that just all the way until 1 plus 93 times 96. And so therefore there are 94 of them. Hopefully no more off by ones on this question, or at least not too many off by ones. There's enough off by one opportunities in this paper. Let's hope it doesn't happen so much again. Finally, and I'll say that this is also a minor miracle that we can say finally about 2 hours 20 minutes into the stream. I feel that I've done a lot of talking, I've presented multiple methods, and my throat is pretty dry, but somehow we're still under 2.5 hours. Just want to say this so that if you're wondering how did that person do so many questions, it means that the time that is being spent is just to do the questions. They already know how to solve them, they've seen these questions before. If you've seen the questions before, it still takes work, but it's achievable. Not easy at all, but achievable. If you have not seen the questions before, don't expect that it can fit into 2.5 hours. Senior is always very time pressed, even when it was not as hard as this. speaking of know stuff, right? Some of you know this is the tangent rule. I had forgotten that this is the tangent rule. Some of you know that. I was like, wait, this looks familiar. I forgot where I'd seen it. And then you said tangent rule. Okay, if you know what the tangent rule is, great. This is actually in one of my notes, and I did not call it the tangent rule. I did not even remember it was called that. So let's just do something different. Let's just do trigo. Step one for any of these kinds of things is that unless you know the tangent rule, there is nothing else useful about tangents. We will shift it to sines and cosines. Why am I writing sine and cosine? Sorry, this is sine at the top for both and cosine at the top below. Now what I'm going to do is that for any of these triangles, it's important to know that the A plus B plus C is 180 degrees is the basis of a lot of these things being nice. In particular, for the C over 2 here, so A plus B plus C over 2 is 90 degrees, means that C over 2 is 90 minus A plus B over 2. Do not need the bracket. Remember what I said about the cotangent just now? Cosine and sine also have that dynamic, and so by doing this, essentially I can just flip both of these into A plus B over 2 by changing or rather swapping the sine and cosine. I'm just deriving the tangent rule, right? For those of you who know the tangent rule, I'm sure I'm just deriving it. Never mind. At least you see that it's not that hard to derive as like being like. I want to then just product to sum both of these, or donate a 2 to both of them, so that I don't have to carry halves around. The product to sum identity is indeed in the A levels only, but it is a SMO thing as well for senior level. So make sure that you either remember it or you know how to derive it using your sines and cosines. Now this one is going to be sine of this plus this, which is A, plus sine of this minus this, which is sine of negative B. I'll just write sine B. This one is going to be sine of their sum again, minus sine of their difference, minus sine of negative B, so it's plus sine B. And then the sine rule will allow you to transition this to just A minus B over A plus B. So humorously enough, it appears that we do not actually even need the length of AB. So your answer is 26. Alright, what do I want to say before we end? First of all, again, this is a hard paper. It is, however, hard in a slightly more of a skewed difficulty than hard difficulty. So for those of you who have been using the last few years of SMOs to practice, it is going to be quite painful. Like, this is definitely very different from that. It is also hard because it looks hard, right? Looking hard makes it hard. You can do some questions. It's just that if you are sort of overreaching, it becomes very scary. So if you're talking about in this paper, the first 10 and a couple of the last few are sort of more manageable. The middle is really hard. But the first 10 look scary. At least some of the first 10 look scary. It's also generally true, so this is not unique to this paper. For the SMO Senior, there are lots of ways to make careless mistakes because of the fact that there are lots of computations, even if you use the optimal approach, let alone if you do not use the optimal approach. So if you do a lot of your practice on your own, just get some idea of what's a realistic score. If you feel that you're around your realistic score, just try to check your answers a bit, right? Stash your marks rather than overreach because some of the questions maybe just you did not know this theorem. And if you're watching this and hearing the theorem for the first time, that doesn't mean you can solve a question about this tomorrow, right? You still need to do plenty of practice to get there. Lastly, a note about syllabus, right? So there's no syllabus for the SMO. If you were to look at the SMO book or the SMO website, what they said specifically is that the SMO will contain some questions which are from the respective syllabus. Let's say for senior, it's year 3 and year 4, sec 3 and sec 4. It does not say that all the questions are contained there. It just says that there are a significant number of questions from there. If you're trying to get a bronze, even a silver, you really only need to do those with high accuracy. But anything beyond that, anything is fair game. As you can see, the last few years' papers all look very different. This year, there's no combi. Please do not assume, if you're watching this in 2025, that there will be no combi in the 2025 SMO. They can suddenly have 7 combi questions. Or they could have 0 again. Nobody knows. Okay, so that's just a few comments. Again, don't be disheartened. Olympiads are hard, but we like them because they're hard. That's why you're doing it in the first place. Okay, so I'll stick around as with yesterday's stream to discuss if you have any questions. Tomorrow, of course, you're welcome to join the SMO Open one, which many of you have been discussing already. Honestly, I'm almost prepared the SMO solutions for Open already, but since the schedule is meant to be for tomorrow 4 p.m, we shall meet tomorrow 4 p.m. Yeah, so I'll stick around for a bit, but for the rest of you who need to go, thanks for watching and have a good holiday break. Do take a look at round 2 if you think you have some non-trivial chance of getting into round 2. It's hard, but still take a look. Open cutoff, my initial guess is that it feels easier, but it is not absolutely easy to get a super high score. So I would say it's a bit higher than last year's, in the 13, 14 range. That's my initial guess would be 13 or 14 for open round 2 cutoff. I'll say a bit more tomorrow because I'm also just sort of like canvassing general sentiment also, and then I'll have a better idea once we get there. Right, so I think I will just wrap it here. It's almost just nice, about 2.5 hours, right? So that's fitting for the SMO. And then see some of you tomorrow for the open review.